So welcome back, everybody, after that short break. Delighted to have you with us again on this truly global event. And it's now time to hand over to our third conference presentation of the afternoon. It's my pleasure to go over to the United States now in Chicago, and James Milburn, the managing principal of the Milburn Demolition Company. Hi there, James. Hi.
Hi, good morning, good afternoon.
Good afternoon for me, but good morning to a lot of people. Good night for the people in Melbourne. You're going to tell us about the Oakmont Point project that your company carried out, which involved 4 post-tension structures connected by interior pedestrian bridges. And if you have any questions for James, please feel free to send them in. I will ask them after James's presentation. So over to you.
Thanks, Alex. As Alex mentioned, I'll be doing the presentation on our Oakmont Point project, which occurred in Westmont, Illinois. As you can see on this cover slide, that's an overview of the top picture is right when we started the project. And then the bottom picture is, I'd say, 3/4 of the way through. Just a brief agenda overview. First, we'll talk a little bit about our company. Then we'll talk about the project, and then we'll talk about the project challenges that occurred on the project. A little bit about us. We were founded in 2014. We have a fluctuating field crew size of anywhere from 120 to 150 employees. We have over 2,000 successful contracts under our belt since starting in 2014. You can read our mission there, but it's providing creative demolition solutions for our customers, safe careers for our people, and bright futures for our families. We place a high focus on our people, as I'm sure most of the people listening do. Our services include complete structure teardown, interior demolition, and then specialty removals. As you can see, there's fire escape removal, water tank removal, so on and so forth. A little bit about me. That was me about 15 pounds lighter pre-COVID. I have a bachelor's of science in construction management from Purdue. I'm currently the secretary of the National Demolition Association. So Oakmont Point overview. Oakmont Point project was a 2-phase project. Phase 1 being the larger phase was December 2018 through March 2019. Phase 2, February 2020 through April of 2020. Total project value was $3.15 million. And the general contractor owner that we were working for was Ryan Companies out of Minneapolis, Minnesota. Ryan Companies, as I said, is the owner and the general contractor. So they offer a variety of services. On this one, they happen to be the one-point contact for the project. A couple of key trade partners I want to focus on, or at least acknowledge, were our crane service provider, which is Stevenson Crane, and they had around $250,000 in work for us on this project. Shoring and bracing, Gilco Scaffolding, about $250,000 in contract values on this one as well. And then probably the largest key trade partner on this project was our post-tensioning and engineering partner, Dewey Dag. I apologize if I pronounced that wrong. Their contract came in around $400,000. So brief overview of phase 1 included a full interior strip out of all the buildings. As Alex mentioned, there are 4 buildings, A, B, C, and D. After the strip out was done, we shored the post-tension beams in building C in order to be able to demolish buildings B and D. Removal of precast facade from buildings B, C, and D. Detensioning, separation, retensioning of the beams at column lines 12 and 9. And the full demolition of buildings B and D down to grade. All concrete from the project was also crushed and for reuse on site. So phase 1, step 1, as I mentioned, full interior strip out of all 4 buildings. You can see all 4 buildings in that picture. A being the building on the right, and then progressing B, C, D to the left. A little bit of a snapshot of kind of before and after what the inside of those buildings looked like. They were commercial office usage. So pretty typical finishes that were removed throughout. Step 2 was immediately following the interior strip out phase. We had to shore the 2 beams that you see highlighted in blue there, from grade all the way up to the underside of the roof, in order to allow for us to separate the structures prior to demolition. That's a picture of what the shoring looked like. And as you can see, that's the thickened beam. It was about a 9-foot wide beam, and post tension. Another picture. Kind of skip through these pretty quick here. So the third step was we had to install cable fall protection so that when we removed the precast facade, there was no fall hazards present. And then immediately following the cable fall protection install, the precast facade was removed. Got a little video of that. And this is of one of the buildings, building C, I believe. It's showing us prepping and picking the precast with a 90-ton all-terrain crane. We had approximately 350 crane picks on this project, which occurred in an 8-day period. And as you can see, that was a time lapse. I wish it would have gone that fast in real life, but that's took a little bit longer in real time. That was, however, I believe half a day's worth of picking on our end. Oop, I don't know what happened there. Okay. Step 4. So this gets into the complicated part of the project. This shows the overview of the bridges between buildings C and D. Building D at the top was to be totally demolished. And as you can see, the bridges that were connecting the 2 buildings were cantilevered out from building C, which was to remain. So this occurred at 2 bridge locations on floors 2, 3, and 4. We had to shore up underneath them. The general scope was to expose and detension the tendons after shoring was installed, locally demolish the bridge concrete, install new reinforcing, form and pour concrete, and then retension the tendons in order to allow building C to stand on its own. Here's a little bit of a zoom shot. This is all the drawings that we had to work with. We didn't have post-tensioning as-built to work with. We just had the existing structurals, which I'll go through a little bit later, but that's a bigger shot of the existing post-tension beam and how it cantilevered across. And you can see the pour stop on that one was located adjacent to building D, which was to be demolished. The picture on the right shows the green section of bridge, which we needed to remove completely. And then the blue line kind of shows where we had to do our retensioning and reinforcing work prior to the demolition. And this is similar condition, but a little bit different on the east side. So between buildings C and B, the bridge cantilever was only halfway between the 2 structures. So you can see how the pour stops in the middle of the bridge, right in that area. But same idea, shore, detention, expose, form and pour concrete, and then retension the tendons at those locations. And that's a little bit of a zoom shot, same scenario here. Where the blue line shows the point of retensioning at the building to remain. And the red section here at the bottom was the cantilever portion that was coming off of a building that we were demolishing in its entirety. Here is another time lapse that shows once the detensioning and retensioning was completed, it shows the demolition of buildings B and D. B being on the right, D being on the left. or towards the end of the video, you can see how they're setting up cranes and concrete pump trucks to enable the reconstruction of building C. Off to the right, you can see building A, which was basically fully gutted during phase one, but sat vacant while they figured out what they wanted to do with it, which led to phase two. Let's see. I won't show this video in essence to save some time here, but that's just showing how we crushed all the material on site in the parking lot adjacent. Let's see. Phase two of the project was in 2020. We came back. We completed the gut of shaft walls and remaining MEPs in building A. We removed the precast facade from building A, and then we created a large roof slab opening for a new HVAC system. There's a little picture of us coming back for the gut. That's the precast removal. And that is showing the roof opening that we had to create on building A. So the challenges to this project. We had three major challenges. First challenge was the schedule on the project. Second challenge was logistics for the building A precast removal that occurred in phase two. And the third, and probably the most in-depth challenge I'm going to go into here is was the post-tension beam and slab alteration scope. So first and foremost, the schedule, phase one schedule was 4 months for all scopes. We were not the low bid on this project. The low bidder couldn't commit to the schedule. And so Ryan came to us. And while the schedule was extremely aggressive, we put a plan in place to meet their schedule, and thus were awarded the project. Second challenge was the precast removal. Building A had a pond to the east, which we were told by the village, we weren't allowed to touch, and nothing was allowed to get dropped in it, or we'd be in trouble with them. So it required a 550-ton crane with a luffing jib. And in addition to that, phase one, building C that you saw on a previous slide, was now occupied. And so was the parking lot next door. So logistics became a little bit more challenging. In these photos, you can see from across the pond, the large crane setup that we had to use for this portion of work. We had to mobilize this crane on a Saturday, which caused a major increase in permitting and just overall logistics and setup costs, which we had accounted for in our bid. And the larger pieces of precast on the east face were 25,000 pounds approximately, which is why we needed such a large crane, due to the distance away from the pick point.
Nando, say hi.
Oh, I left a little audio in there. Apologize. There you can see the one of those large precast picks utilizing the 550-ton crane. And I'll skip to the next one. So the third challenge, which I'm going to go into a little more in depth, was the post-tensioning alterations. As I mentioned before, with demolition of structures D and B required us to detension and retension the bridge connections between the buildings, so that building C was stabilized on its own. The existing bridge spanning from building C to B was cantilevered to the midpoint, which I showed you earlier. The discovery occurred in the field that existing beams to remain were not reinforced per the existing structural drawings, which required engineering changes in the middle of the project. So this plan here was the original plan. So the bridge that was getting severed was to have about a 18-inch cantilever at its final pour position. The picture on the right shows the condition in the field that is shown on the plan on the left. So this is what originally we were supposed to do. This only ended up working at 2 locations. I think 6 of the other locations required this updated plan where they had to shrink the overhang in order to accommodate the new facade that was being installed. As you can see, the overhang limit was reduced from 18 inches to 3 inches. So that required a few changes. The first one being we were required to custom fabricate anchors because in order to spread the weight of the post tensioning work, the anchors had to be much closer together. This plate, while it doesn't look that complicated, is very hard to manufacture. Luckily, in Chicago, we have somebody close that was able to turn those around fairly quickly to avoid major schedule impact. Then due to this anchorage change, it required a bursting steel modification. So traditional rebar reinforcing was not going to work at these locations due to the shrunk space, or lesser space to work with. So we ended up using tension rods welded to steel plates, and this eliminated congestion that we were running into with typical rebar methods. It also allowed us to make the parts fit around the existing PT without interfering with their existing locations. And the third setback we had was that a couple of the 2 of the locations, I believe, had an issue with the post tension anchors running through the column at the perimeter of the structure. The only way to accommodate the 3-inch maximum overhang was to actually create a pocket in the slab inward of the column and create a new place to retension cables. And so as you can see there on the right, that's showing you those pockets that were created. The other challenge, which will probably go back to schedule more than anything, is due to the project delay, the initial kickoff delay. We hit the winter months in Chicago with a fully gutted and facade removed structure. We had to create tents and install heaters and make sure that the concrete pourbacks were kept to the right temperatures so they could get to strength. In a couple of cases, this also required us to have a monitor on site 24 hours to make sure there was no issues with the heaters or the tents. Little bit, I'll show a video about this. It's a overview video of the whole project, so you can see kind of start to finish. let's see, I skipped one. Let's see. As a result of the project, or the end result was we worked over 13,000 man hours on site safely. We won a safety award from the general contractor, Ryan Companies, as their 2019 subcontractor safety award. And 98.6% of all demolition materials from the job were recycled and or diverted from the landfill. That's a quote from our customer. And that's the end of my presentation. Thank you for your time. I appreciate the opportunity.
Thank you very much indeed, James, and for that fascinating video. It's certainly interesting to watch it all speeded up and the challenges that you talked about. We have a few questions. First of all, what in particular was different about this project compared to others in Milburn's history?
The largest difference in this project was the post-tensioning alterations. The building structure type on this project was one that we haven't encountered prior, and I don't expect to encounter a similar condition in the future. So it created a unique impact on working with our post-tensioning contractor and the general contractor and the 2 engineers of record, to make sure that the project wasn't delayed during those changes.
Another question, can you talk a little about the concrete crushing requirements of the project?
Yeah, so all concrete was crushed into 3" minus and CA6, which was separated into 2 different piles and then utilized on site when the earthwork contractor regraded the locations where the 2 buildings were demolished.
Okay, and last question, can you tell us a little bit about the building information modeling? Did you work with that or not?
We did not do any BIM on the project. We had the structural engineer of record had an initial design set, and then our engineer, which was hired through the post-tensioning contractor, had basically submittals that were specific to the retensioning process. Those 2 engineers worked closely together to when the reworks were required, but no BIM was used on the project.
Okay, thank you very much. I have a personal question. Are you ever going to get a president? Do we have a result soon or not?
I thought we were going to go there, Alex. I don't know. I think, I would say by January we will.
Okay, perfect. Thank you for that scoop then, James. Thank you so much for that very interesting presentation. Thank you. So now we go over to the second group of awards announcements.